Welcome to Careless Coder, and today I will be reacting to Andy Serkowitz's video on how to become a better problem solver. Motherfucker! Andy Serkowitz is a self-taught software engineer, JavaScript C# developer, and in his YouTube channel he will help other self-taught developers land their first job. Now generally his information is pretty decent, although it always scratches the surface, and that's a problem with all these channels that have popped up where people will promise you advice to land your FANG job and earn $250,000. You will not. Trust me.
There's a problem that has troubled philosophers for millennia now. Philosophers like Plato and Socrates have wondered, why is it that programming tutorials aren't making everyone programmers?
Now that is actually pretty funny, to be honest. It's a quirky, dry sense of humor, but it's funny. I like it.
I know that many of you right now who are watching this know exactly what I'm talking about. Maybe you've gone through 100 hours plus of tutorials and yet you still can't build the simplest project, or you can't even complete a simple programming challenge.
Tutorials are the worst way to learn programming, bar none. It is great to get a feeling of a concept quickly, but that is it. If you want to learn programming, you have to go back to the fundamentals. And the best way of learning fundamentals, how old-fashioned as it sounds, is a book. Because books are edited and structured in such a way that all the knowledge stacks on top of each other. So if you want to become a good developer, start first learning the fundamentals from actual books.
Now there are going to be some people who are going to tell you that you just don't have it, right? This it factor, this magic power that if you've been studying this long, you don't get it, just go ahead and quit. Go try something else, right? But I don't believe in it factors.
Now I totally disagree with this. There is definitely an it factor. Not everybody is laid out to be an engineer. That requires a certain wiring of your neurology. Not everyone is wired to be an awesome painter. You can learn the basics, again, the fundamentals, and you can progress, you can hone that skill. But you need that it factor, that magic sauce, that X factor to make you truly great at this. And I think with engineering, that is more so than with any other profession.
I don't believe in magic powers. If you are stuck learning to code, if you're stuck in that tutorial purgatory, there is a way out. And in this video, I'm going to lay out some strategies here to get unstuck so you can get back on the path of learning to code so you can get into this as a career. So let's go ahead and dive in.
Well, I'm curious to see what he does to get these Gen Zers and millennials out of this tutorial purgatory. I like that word, by the way. And I'm glad that we were raised in the 70s and the 80s when we didn't have tutorials.
So what exactly is it that's causing you to go through this endless cycle of tutorials without making any progress?
My answer to that? Laziness.
Well, it often comes down to this. You're missing the point. Tutorials are an excellent approach to learning how a specific programming syntax works, or seeing the examples of how to build certain types of projects.
Seeing examples on how to build certain types of projects. That's exactly what I said. It's an ideal way to get concepts across, nothing more than that.
However, the one thing that tutorials can't do is that they can't teach you how to problem solve.
I'm with Andy on this. Problem solving cannot be taught by watching tutorials, nor by reading books, nor by going to college. Because that is that part that is creativity. They try to hone that skill, they try to give you questions that will hopefully trigger you to think about these things. But they can't teach you on how to think about those things. And the most important thing with problem solving is also experience. The more experience you have in the whole world, the easier it is to problem solve.
Now, if you've heard this before and you're like,
"Oh, Andy, I've already heard this before."
I'm just going to stop you right there. This for you should be your white whale. This should be the one thing that you focus on relentlessly. It should not be below you. It should not be too good for this, because if you don't figure this out, you will continue to go through this process over and over again where you're not actually learning anything. Now that you've identified this as a weakness, you want to attack this head on. And the first thing you want to do is really develop and follow a repeatable process for problem solving. You don't want to just jump in and start writing code. Now, I recommend a 4-step problem solving process that you're going to want to write down here. So the first part of any problem solving process is, number one, understanding the problem.
Understanding the problem is indeed the most important part, but it goes beyond understanding the functional problem. You need to be able to drill down to all the technical aspects of that functional question, and that is really difficult. And again, that is where world experience comes into play.
That means when you're given a programming challenge or a project to build, you want to write out everything to make sure you understand it. I'd say the biggest problem so many of you guys have is that you just leave everything in here, right? So you leave all your thoughts rattling around. If you're like me, you have ADD.
Another precious millennial with ADD. It seems like a bloody pandemic, more so than COVID ever was.
It's so overwhelming. So the first thing you want to do is get everything from here out onto paper or onto a whiteboard.
And he's driving home here the point of getting it onto paper. Actually, what he should say is getting your thought processes structured, your train of thought put down in a nice, organized little line. And if you do that by writing it down, if you do that by role-playing, if you use actual props, it doesn't really matter, but it's all about getting your train of thought in order.
And you want to just ask yourself questions. You want to say, what are the inputs of the problem? What are the expected outputs? Are there any rules or constraints? Write down any questions you may have. Get it all out until there is nothing else left so that you can see it and you can play around with those ideas. From there, the second step in this process is to break the problem down into small chunks.
Chunking is indeed a very fundamental part of problem solving. And it's one of these parts that is very hard, if not impossible, to teach, because you need to rely on your previous experience. So without experience, which again requires the fundamentals, it requires you having done stuff, you are not able to chunk down a problem, especially an abstract problem.
Right, so just like you have a favorite meal that you may like to eat, if you were going to tell somebody else how to make that, you have to break that down into small steps. So if you get some sort of programming challenge where you have to reverse an array.
This is where the wheels start to come off the wagon. He's going to show how to reverse an array, and his solution is the worst possible solution. When this is actually a really simple and great way to demonstrate how to think like a computer scientist. And he doesn't do that. So this is where he misses the ball completely.
Right, that's a pretty common one. How could you break that down into smaller steps? Don't even think about the code. Don't think about anything else. Just play around with some certain ideas and break that down into the small steps possible so that you can then move into the coding process.
So here Andy demonstrates that he himself doesn't understand the problem in a fine enough detail to come to a efficient solution. He immediately makes an assumption, create a placeholder. Whenever you're a developer and you create a placeholder, instantiate a new object, instantiate memory, you need to ask yourself, do I actually need that? Do I want 2 copies of the whole structure in memory? Because 9 out of 10 times you don't even need that. And I guess that's why a lot of software that is written now is such a bloatware, because people don't really think about these things.
Now, the third step in that process is actually to go through each of those steps and convert that into code. So if you've broken things down, you should be able to look at things and say, okay, knowing what I know, the hundreds of hours of tutorials I've put in, of knowing the basic syntax, control flow statements, how can I convert this into something that produces the output that I want? And just go through and play with it, right?
And here you see the result. A poorly understood problem, a poorly described problem, is a poorly generated algorithm. Now let me show you how I go about actually trying to figure out optimal algorithms. And it's a lot more complex and a lot more involved than Andy makes it out to be. So this is reversing the array the smart way, and I will show you my train of thought on how to analyze this problem and come to a more efficient algorithm. Let's first have a look at Andy's code. He creates a placeholder array, an empty array, then iterates through some array in reverse, reads each element from that array, and then pushes it onto that new placeholder array, basically creating an extra copy and iterating through all elements. Is that truly necessary? That is something you need to ask yourself. And asking yourself these questions is the infamous big O problem in computer science. Do we truly need to iterate through all n possibilities? A good developer will always wonder, do I need to have a copy of a structure in memory? Because that is inefficient. Can I optimize this? That is the next question you should ask yourself. So this is what Andy did really well. identify the input and the output scenario, and then you visualize the problem. That's what Andy did with writing it down. You can do it by writing it down on paper. You can actually role play it with items. In this case, that would be very easy with different colored marbles that you swap around. You can talk yourself through the process. Or in this case, I animated it for you guys to really have a visual idea of what the problem is. So when you visualize it properly, you will see that we actually are swapping digits and moving over the index. And then halfway done, the middle one doesn't need to do anything. So let's watch this again. We're swapping 5 and 1, then we move the index over, swapping 2 and 4, and when we're done, the 3 doesn't do anything. So you need to find a pattern in your problem, and when you find that pattern, you can actually then describe it mathematically, and that is when you found your algorithm. And only when you have identified the pattern and described it mathematically, then you will start to write the code. Now I know that the word mathematically strikes fear in the heart of 90% of the software developers, including myself, but luckily our mathematics is applied and usually relatively simple in these cases. So when we look at that animation, we see that we're actually swapping the two indexes, the one at the beginning and the one at the end. So B becomes E and E becomes B. That is basically what we're doing. And B is of course the lower index of the item that we're going to swap, which is basically our iterator, our I value. And E is the upper index of what we're going to swap. And since that is moving in, it's basically the length of the array minus the offset, minus the beginning offset. And these couple of very simple formulas are your algorithm that we're now going to implement. Because Rust is cool, let's install Rust. So you go to rustling.org and you copy this little command string, you open a terminal, you paste it in there, and everything is then installed. The whole toolchain, the compiler, everything. You cannot get a more easy install than this. This is already worth it for me. After restarting your Visual Code, you open a terminal and we're going to create our first project. You go into the directory where you want that project, type cargo in it and give it a project name, reverse array in this case, press enter, and if you go into the directory you will see that actually there is some boilerplate already created for you. Let's open up this project and let's start coding. And then here we see our main.rs that we're going to use. What I really love about Rust is that your test code is an integral part of your source code. So no separate files, no separate frameworks. So let's create our test code first. It's always good to start with a failing test. So we give the compiler directive and we will put all these tests in their own little module called test. This is an arbitrary name. And each test we will annotate with hashtag test. That way cargo test knows what to run. And that is hashtag test. So now we can write our test function. Functions start with the fn keyword in Rust. And of course we need to import our crate with the actual functions. And you can do that with use super : asterisk. Or in this case, since we only have one function, crate and then : with the function name that we're going to import. I'm missing a use here in front of crate reverse. I will create that later on. So here we create the function definition. We have a function called array and we pass in a mutable array of type integer 32. The ampersand sign in Rust means borrow and you can basically look at it as pointers. So now we need to create a mutable array for our input, and mutable because we're actually going to update the actual values within that array in our reverse. So 1, 2, 3, 4, 5, that is our input. Of course it's not a string. Typing. And then we need to create two outputs, and they are not mutable because we're not going to change them. And Rust compiler is actually very finicky about that, and that's a good thing. So again, i32, semicolon 5 means 5 i32 values.
We copy this, make an output 2, so when we run the test twice, we have the same value as we started with. And now we will call the reverse and we borrow the input 1, so it will actually reverse the values in the array called input 1. And then we call an assert equal macro. The exclamation mark is a macro, it's not something that we are bothered with. And we pass in a borrow of input and we pass in a borrow of output 1. So they should be equal. Yep. Output 1, there we go. And then we copy this again, we run it again, and then input should be equal to output 2. And here I see that I missed the use, so let's add that. And of course we pass in a mutable because we're going to change the value of input. And that is the mut, that stands for mutable. This language is so nice and clean. It forces you to program very thoroughly, and I like that, to be honest. It's initially finicky, but then it works. Let's run this test and it should now fail. Yeah, we have a failed test and some warnings, and yeah, we will fix these as we go and implement it. So let me quickly write a main function that takes in an array, reverses it, and then prints each of the elements in the array using a for in to the screen like this. Okay, now let's implement the reverse. So first we need to have a temporary value, and it needs to be mutable because we're going to change it, and it is of type i32, the type of the array. Now we can loop through the array from index 0 to actually the arrow length divided by 2. So we're twice as fast as Andy's algorithm. Dot length divided by 2, open curly braces. You need curly braces in the for, that's a bit weird. What's this error? What is it complaining about? I don't see it. Let's hover over it. Oh, you need an in. It is for I in. So first we need to save what is currently on array index I. That is our temp. And then we can use that temp value later on to override what is on the opposite side. But first what is on the opposite side, which is basically array.length minus 1, because arrays start at 0, minus I, which is the offset in the array. And we copy that onto array I on the current index. And then we take the opposite index and we put the temporary value on there. So what is in array I? In temp, of course. We already overrode array I. Temp. Yeah. And this is the faster way to do this. Let's run cargo test. Our tests succeed. Awesome. Let's do cargo run. And we will see our program works as well. And this is the better way to do it.
So that actually is a more efficient way to reverse an array. Now this video isn't about reversing arrays because I know that most of my subscribers are senior developers with also 30+ years of experience. They know this shit. I hope they learned something about Rust, which is a cool up-and-coming programming language, and I think it's brilliant. I really start to fall in love with it. But the main point I try to drive home is that all these channels that try to teach people how to code and land a job in the marketplace as a programmer, no matter how well their intentions are, they themselves often are not experienced enough and they are not educators. I am not an educator. I trained several interns and I always found it extremely difficult to teach them problem-solving skills. And frankly, I didn't teach them, I coached them. I just asked open-ended questions. Why aren't you asking yourself this? How could you do this differently? Why are you using this solution? And hopefully those engagement processes will actually start to make them think creatively. And with each time that you do a project, you gain experience, and all your experience will help you to become a better problem solver. That is the only reason why older people get paid more, because they have more experience and they can more easily solve a problem, and often a lot more quickly as well. So I hope you learned something. I sort of like these reactive videos, so maybe I will do another one every now and then, and I hope to see you in the next one.